Hello everyone, welcome back to our course. So far in this course, we have covered Python fundamentals, decision makings, loops, functions, data structures, object-oriented collections like lists, tuples, sets, dictionaries, and most recently we have gone through the strings. Now it's time to move into one of the most important topics in Python called object-oriented programming. If you want to become a professional in Python developing, learn Django, Flash, machine learning, AI, ML, game development, automation, and find oops you will find oops everywhere. Almost every large project is built on oops, object oriented programming. So today the lesson is a major milestone in our Python journey. Let's get started. Before jumping into the code, let's quickly see what we will learn today. We will begin by understanding what object-oriented programming is and why programmers prefer it over procedural programming. After that, we will learn the two most important concepts, classes and objects. Then we will understand constructors, the self parameter, instance attribute, and the class attribute and methods. Once the basics are clear, we will move to the three major pillars of OOPS: encapsulation, inheritance, and polymerization. Finally, we will learn how Python modules works and how to import involved Python libraries and how to create our custom module. And we will finish with two practical questions, and by the end of this episode, we will learn how to become a professional Python application in a structured way. Now, before we learn OOPS, let's find out why it was introduced. Imagine you are writing a very small Python program using normal functions is perfectly fine, but as your program grows or your project grows, things becomes difficult. You will need to learn hundreds of functions, hundreds of variables, and everything gets mixed up. The code becomes difficult to understand and hard to maintain, and even harder to debug. This is called procedural programming. As projects become larger, procedural programming starts creating problems. Now imagine another approach. Instead of keeping data into one place, the function somewhere else. What if we combine both together? For example, a student has a name and a age, marks, and also actions like studying, attending class, and displaying information. Instead of storing these separately, we bundle them into one unit. This is exactly what object-oriented programming does. It groups data and behavior together. This makes programming much more easier and cleaner and more organized and easier to use. Let's compare both approaches. Without OOPS, large programs usually become messy, repetitive, and difficult to maintain. With OOPS, the code becomes modular, organized, and reusable, and much easier to expand in the future. That's why almost every professional software project uses OOPS. Now think about building a city. If everywhere building was created without the proper plan, the city becomes chaotic. Roads wouldn't connect, electricity wouldn't recognize, organize, maintenance would be a nightmare. And architectures built a blueprint for the first, then built houses using the blueprint. OOP, it follows the exactly same idea. Now, what is a class? Let's understand the first building block of OOPS, the class. A class is simply a blueprint or a template. It describes what an object should look like and what it should be able to do. Notice something important. Creating a class does not create any real object. It only defines the design. Think about an architect's blueprint. A blueprint tells us how the room will have, how many rooms the house will have, how many doors, how many windows will it have. But can you actually live in the blueprint? Of course not. The blueprint is only the design. Similarly, a class is only a template. Let's create our first class. Class student pass print a student. Let's understand it. The keyword class Here tells that we are creating new class. In the class name, by convention, the class name begins with the capital letter S, and it means do nothing for now. Now it's simply a placeholder. And student print student prints information about the class itself. Notices we haven't created any student yet. We have only created the blueprint. Next, what is an object? So an object, if a class is the blueprint, then object is the real things created from the blueprint. Think of a car factory. The factory it has one design, but from the single design, it can manufacture thousands of cars. Every single car is different, but there is all built from the same blueprint. Similarly, one class can create many objects. Every object has its own memory, its own database. Something like this. It will look. See, there are multiple classes here. Let's understand this carefully. The line S1 equals to a student and the S2 is also a student creates another object. Although they both belong to the same class, but they are different objects. When we print them, Python shows different memory address. And that means objects, each object occupies have its own memory. So one class can create 10,000 or even a million objects. Think about a cookie cutter. You have only one cutter, but you can make hundreds of cookies using the cutter. The cutter is the class and the cookie is the object. Now let's create our first class. For that, let's move to the coding. Name equals to John, then student equals to student, then we close the bracket and then print student dot name. Let's understand every line. First, we created the class student. Inside it, we created the attribute called name and assigned it value John. Next, we created an object named student, and there, using the dot notation, we have accessed the attribute. Go inside the dot simply means go inside the object and get its name. Output should be John, so it's got the John. Dot notation is one of the most common thing you will see while working with OOPS. You will understand this more in further. Now that we have understand what the classes and objects are, it's time to make our classes more useful right now. Every object we create is exactly the same, but in real life, every student is different. One student may named Alice, another may named Bob, and another Charlie. So the every person is different. How do you give different data to different objects? That's where constructors comes in. We will also understand the mysterious self parameter. Learn the difference between instance and the class attribute. Create your own method and finally see how one class. Imagine you are buying a new smartphone. The moment you switch it on, it automatically performs some setups. You don't need to manually tell it to initialize memory, load operating system, or prepare the interface. It's happened automatically. The Python constructor works in the exactly same way. Whenever a new object is created, Python automatically calls a special method called the init. So its job is to initialize the objects with the required data. So let's build our first constructor. under double underscore, two times underscores, and then the self will be always present, and then a name. After that, self dot name, where we will give name as the name. After that, we will go with this will be more outside. So s1 dot no dot not equals to student, which will be Alice. Now let's print s1 dot name. To the spelling error. Now let's understand every line carefully. Basically, we have defined a constructor here, and notice the double underscore before and after in it. This is after a special method provided by Python. We will should never rename it. Now look at that self dot name, and where we are assigning name, and the value comes into it like Alice. It is stored inside the current object. We created an object called S1, and where we have assigned a student and a name as Alice. The moment Python sees this line, it automatically calls the init, where we never call it ourselves. It's called automatically. This is the form of constructor as a registration form. Whenever new student joins a school, the school immediately records their name, roll number, class, and similarly the constructor immediately stores the object information. Now, understanding the self parameter. So now let's understand the most confusing topic for beginners, the self parameter. Many students think self is a keyword, but it's actually just a variable name. Its purpose is very simple. It's referred to the current object. Whenever Python calls an instance method, it automatically sends the object itself as an argument. Let's see with an example. S2 dot name S2 equals to S2, then it will be S capital, then Bob, print S1 dot name, print S2 dot name. Now notice something interesting. Both objects use exactly the same constructor, yet each object has different data. Why? Because self points to the object that is currently being created when S1 is created using self. It refers to only S1. When S2 is created using self, then it refers to S2. That's exactly why every object gets its own independent data. Think about writing your name on your own network. Everyone follows the same process, but each notebook different belong to a different student. That's exactly how self works. Now let's understand the two important types of attribute. So the first type of attribute is called instance attribute. These belong to individual object. The second type is called class attribute. These are shared by every object created from the class. Let's see both in the coding platform. Def init self comma name self dot name equals to name, then s1 dot student alice, then we will go with print student dot school, and s1 dot name. Now clicking on run, is okay, this yeah, take this. Ah, now let's understand. The variable school is written directly inside the class, outside every method. So it becomes a class attribute here. And every student belongs to the same school. So schools, so this is a value is being shared by everyone, just like a global variable you can think. And then the self name, it is created inside the constructor. So every object has its own. So it's an instant attribute. Imagine a classroom. Every student studies in the same school. That's a class attribute. But every student has a different name. That's an instant attribute. Now let's move to methods. So until now our class has only stored information, but objects should also perform actions. Functions should define inside a class are called methods. Let's create one. Def display self print f f string means student name self dot name, then s1 equals to a student John. Then we will go with S1 dot display and clicking on run. We can see we have defined a method called display, and inside it we have printed the student name. Now look at this line, s1 dot display. Instead of calling a normal functions, we are calling a method using the dot operator and getting the output student named as John. Method allows objects to perform actions, making class much more useful. Think of a car. Car has data like brand, color, speed, but it also performs action like start, stop, accelerate. Those actions are represented by method. Now let's see why a loop is so powerful. One single class can create as many objects as we want. Every object gives its own information. Let's see with an example. Self dot grade equals to grade. S1 equals to student Alice gamma A. S2 equals to the student Bob comma yes print s1 dot name comma s1 dot grade, then print s2 comma dot name comma s2 dot grade. Here will be grade. Now, notice both students were created from the same class, but changing one object doesn't affect the another. Each object has its own memory, now its own attribute, and its own data. That's why one class can represent thousands of students, employees, cars, or even bank account details all independently. For this, think it like a school database. There's only one student class, but it can also store information of every student in the class. In the school, each student has a different details. They are all created using the same blueprint. That's called object oriented programming. Now that our class data and perform action, it's time to make something powerful using object oriented programming. Why it's truly powerful? Its core principle in this we will learn about the first two pillars or of OOP, the encapsulation and after that inheritance. These concepts help us to write secure, organized, and reusable code. And once you understand them, you will begin to see why we use them in large software applications. Let's continue with the pillar one called encapsulation. So the first pillar of object-oriented programming is called encapsulation. The word might sound difficult, but the idea is very simple. Encapsulation basically means keeping data and the methods that work on the data together inside the class while protecting important information from direct access. Think about your mobile phone. You can increase the volume, change the brightness, or connect to Wi-Fi. But can you directly touch the internal circuits? No. Even think like you can even touch battery controller or the processor. No. These are inside the inside internal system that gives you safe buttons to interact with. That's exactly how encapsulation works. It hides sensitive data and provides only controlled access. Let's understand why this is useful. Imagine you are creating a bank account. The balance should never be changed directly. Instead, the user should use methods like deposits and withdraw. This ensures that invalid operations cannot accidentally damage the data. That's one of the biggest advantage of encapsulation. According to our slide, encapsulations has three major benefits. First, the data security. Sensitive data is protected. Second, the validation. We can check everything whether the new value is valid before storing it. Third, the maintainability. We can change the internal implementation later without affecting the rest of the program. Professional software relies heavily on this. After that, there comes private variables. Now let's see how Python hides data using private variables. Python's uses double underscore before the variable name. Let's see with an example. Class bank def init self dot double underscore balance equals to 1000 account equals to bank print account dot balance. So now let's understand how the constructor is working. For that, let's inside the constructor, we have created a variable named self.balance. Notices the two underscore. The two underscores tells Python that this could not be accessed outside the class. Now look at the last line, print account access. This will give an error. And Python's gives an attribute error because balance is private. Python intentionally prevents it from direct access. This doesn't mean the data is lost. It simply means we should not be able to access it without using the proper methods, which we will build in the next question. This keeps the programming safe. Think about an ATM machine. You can check your balance, deposit money or withdraw money, but you cannot directly open your bank's database or change bank's account number. The ATM gives you only with the safe interaction. That's exactly how encapsulation works. Now moving on to inheritance. The second pillar called inheritance. Imagine you already have a class that contains useful code. Instead of writing the same code again, wouldn't it be better that another class could simply reuse it? That's where what the inheritance does. It allows one class to inherit the properties and methods of the another class. This avoids duplication of the data and methods programs easier to maintain. Let's understand this with a real example. Every dog is an animal. Every cat is also an animal. Animals can eat, sleep, and breathe. Instead of writing these methods separately for every animal, we can write them simply once in the parents class, and all children can receive them. So, let me explain you with the coding. Uh, so for that class, animal def eat self print eating food. After that, class dog parent class animal def bark self print woof woof. Now D equals to dog D dot eat D dot bark. Let's understand this carefully first. We have created a parent class called animal here, and it contains one method called eat. Next we created another class called dog, and that word animal inside the brackets, which means it inherits properties from animals. Now even though dog cannot doesn't define an eat method, it can use it. So the output becomes eating food and woof woof. And this code reuse instead of writing eat again and again. Dog simply inherits it. This is about a family. Children inherit many characters from the parent. Similarly, child class inherit many characters from parent class. That concept is called inheritance. So, Python supports different types of inheritance structures. Let's understand each one briefly. In brief, single inheritance. One parent inherits to one children. Example: animal is dog is under comings under animal. This is simple. The most common term. Then there comes multiple inheritance. For example, a class may inherit features from both teachers. A class may inherit features from both teachers and researchers. Python support this, although beginners doesn't use it often. Then there comes multi-level inheritance. Inheritance continues across multiple generations. For example, living things are like animal, dog, and here dogs inherit indirectly from living things through animal. Hierarchical inheritance. One parent's can have multiple child class. For example, animal can also have dog, can have cat. Both dog and cat inherited the same parent. As a beginner, you don't need to memorize every diagram. Just remember the basic idea. Inheritance allows classes to reuse existing code, making programs much more shorter, cleaner, and easier to maintain as you build larger programs. These inheritance patterns becomes very useful. Now, as we have learned let's move to the next pillar called polymorphism. The word polymorphism comes from two words called poly, which means many, and morph, which means forms. So basically, polymorphism means one interface and many forms. In Python, different classes can have methods with same name, but each class performs its own version of the method. Let's understand this with a real life example. Imagine if you have different animals to speak. A dog barks, a cat meows, a cow moves. You are asking the same question to everyone speak, but every single animal responds a different way. That's exact what polymorphism. The names is the same, but every behavior depends on the object. Let's show you with an example. Class dog def speak self print roof class cat def speak self self print near for animal in dog comma cat animal dot speak. Now let's understand it carefully. First, we created a dog class. It contains a method name speak. And then we created cat class with method name speak. Notice both methods have the same name. But finally, we create a list containing a dog and cat and we have looped it through so that we can use is animal dot speak for both, and Python automatically decide which version of speak should we execute first. First the woof and the meow. This is the ability to perform different actions using the same method line, and this is called polymorphism. Think about a TV remote. You press the power button, whether it's a Samsung TV, LG TV, or any other brand's TV. The same button performs the appropriate action. The interface is the same, but every device behaves different internally. That's polymorphism. Now, let's move to the oops move away from the oops for some time and learn about modules a little. As programmers, we don't write everything from scratch. Python already gives thousands of ready-made functions organized in codes, and those are called modules. A module is simply a Python file containing useful functions, variables, and classes. Instead of rewriting every code, we simply write or import it using the module and start using it. Python provides many built-in modules. Let's look at some of those. First one is the math module. So math module provides mathematical functions, for example, square root, power, trigonometric function, and mathematical constants. Then there comes a random. The random module generates random number of random choices and can even shuffle lists. It's commonly used in games, password generation, and simulators. Then there comes date time. Date time module helps us with date, times, and calendar. Whenever an application displays today's date or record login time, it usually this module. Then there comes OS. So the OS module allows Python to communicate with the operating system. It helps us to work with the folders, file, dictionaries, and system paths you will see frequently used. Think of module as a toolbox. Instead of creating your own screwdriver, hammer, or wrench, you simply open the toolbar, use the tool you need, and the module do the exactly same way. Now the import one. So the import one is basically it's the simplest way of using the import. The statement, let's see with an example. Here we can go with import maths. Then result equals to math dot square root, and we will do the square root. Then we will print the result, and after that we will print the math dot py. Let's understand each line. Here we have imported the maths, which loads the entire math module, and now every functions inside the math module can be accessed using the dot notation. For example, math dot square root or math dot py. Using the module name before every function keeps the code organized and avoids naming conflicts. Then the from import, we only need one or two functions from a module. So writing math every time becomes unnecessary. Python provides another option. So that option is from module import function. Like let me show you with an example. From math import square root and pi, print the square root 16 and pi. Then there comes print pi. Let's understand it. Instead of importing every module of maths, we have just imported the pi and the square root. Now we can call them directly. No need to write math dot square root and every time all that. Things make these coders shorter, easier to understand. However, be careful. If two modules contains function with the same name, direct imports can sometimes create confusion. That's why many professional developers still use the old method. Then there comes, let's compare the both approaches. So in the first one, the name becomes visible, and in the second, the codes become shorter, but the functions appears directly in the program. Both methods are correct. Choose the best one that suits your project. Now as we have done with the built-in modules, now we will go with custom modules, which is simply a Python file created by you, containing functions, classes, or variables that can be used in the program. Instead of copying the same code again, we can place it in one file and import whenever we will need it. Think of it creating your own toolbox. Whenever you need any tools, you simply open the toolbox and use it. Let's create our own custom module, and suppose we have two files. The first file is named calculator.py and the second file is named main.py. So for the first file, we will go with. Now let's understand this. We created two simple functions. The first functions adds two number and the second functions subtracts. There is no main program here. The file only stores when the reusable. That's why it becomes a module. Now going to the second file, import calculator, and understand the first line. So basically this will happen more when we will try to code it in the offline method. Means when we try to save the file, then we done the process, then it will be more easier to understand. So basically let's skip this topic. It may confuse you if you will not do that, if I will not do that way. So skipping this, let's move to another question based. So moving class, a student, manager, def, init, self, dot students equals to square bracket, then there comes def add students self comma name, self dot students dot append name, def display all self for a student in self dot students print as students now here look carefully. And don't let's get the first we have created the student.manager class, and inside the constructor we have named a list students, and then we try to add student names using the method, and whenever we call that, the new student names will be added in the list, and after that we have created the function display all. Now let's create our classes. Let's use our classes. Create now manager equals to a student manager dot add students Alice manager dot add students Bob manager dot add students Charlie. Then there calls manager dot display all. Add student. Basically, we have done the add student manager spelling again mistake. Now what happened? The manager is not defined. Manager MANAGER. Right. Yeah. The data remains inside the block instead of using global variables. Everything stays in the organized inside of class. This is exactly how object-oriented programming works. This helps us to build a clean software code. This is exactly how school files when a new student joins. Their name is added to the school record. Later, the office can print the complete student list. Our programs work in exactly the same way. Now, I'm moving on to another question. The bank account balance. Let's understand this step by step. Let's understand this carefully. Inside the constructor, we store the balance. And notice the balance uses underscores, which means private variable. Users will never able to modify it. Instead, you can use method, the deposit method, to increase their balance, and the get balance to safely access the current balance. Now let's test the program using we can see the account balance start with 1000. Next we deposited 500, and finally the objective that when we try to access the current balance we have got 1500. And that's everything happens through objects. That's exactly how real banking protects customer data. Imagine if you are visiting your bank, you don't need to open your bank database. Just type your balance and new balance, and instead you request a deposit, withdrawal, and balance inquiry. And the bank performs the actions for you, and our class follows the same principle. How everything connects. Let's take a moment to see how the concept we have learned work together. So basically the class provides the blueprint. The constructor initializes each object, then the self parameter stores data inside the object, then the methods performs action. Encapsulation stores sensitive information. Module allows us to organize these classes into multiple files. Then these concepts come together and build the foundation of professional Python programming. Now, moving on, let's see some few common mistakes that beginners often do. Once you understand them, you will be able to avoid them. Mistake one, forgetting self. So basically, one of the most common method mistakes is that people forgot self itself inside the brackets. So inside instance methods. So let's see an example. Here you can see here we have forgotten this. Here there is no need of self, but when we create an object. You can see there comes an error because we have forgotten the self that need to be here. See that now it's work properly. Another mistake is forgetting to create an object. Sometimes beginners write codes like this. And they try calling which cause an error because they need to first define the method, then they need to call. See, that's the then dot notation. So then there comes import mismatch. Means there is nothing that you are importing exists. Like if you cause an spelling error, or that will cause a module not found error. Now it's your turn. Practice, pause the video and do some questions by yourself. Create a class. So basically the first question is create a class called car, and the class should contain two attributes, brand and speed. Now create a method called accelerate. Whenever the method is called, increase the speed by 10%. For example, if your speed is 10, after calling accelerate, it should become 60. Next, the question is shapes and inheritance. So in this, you need to create parents class called shape. There, you need to create child classes called rectangle, and that inherits shapes and adds area using the method inside the rectangle class. That's using length into breadth. And this exercise will help you to understand inheritance and method creation. Try solving by yourself before checking online. Now let's summarize today's what we have done. Let's quickly revise. So we are started by understanding why object-oriented programming is important. Then we learned what class objects are. After that, we explored constructors, the self parameters, instance attribute, class attributes, and method. Next, we studied three major OOPS pillars: encapsulation, inheritance, and polymorphism. And then we moved Python modules, learned how to be used built-in, how to use the built-in libraries, and finally built a student management and bank applications basic question. If you have understand everything we have covered today, you are good to go with the OOPS. These concepts are used in almost every Python project, so mastering these will help you a lot. That's all for this today episode. Thank you for watching. That's all. So keep practicing. Thanks for watching.